my recordings have been taking longer to encode, so I'm been a little slower getting them posted up online there, so I apologize that there. Okay, what I intend to do today, and we may run the full hour, we may run a little shorter, we may run over, it just depends on how many questions you've got. But I'm going to be going through the software that we're going to be using for the rest of the semester. And there's only 3 or 4 weeks, but there's going to be a project assigned for it. You've got a couple of things to do between here and the final. I'm going to have a practice test, which will be graded. Plus, there'll be a lab that you'll use the software where you'll have to design a basic system there. And before you get too upset about the project, keep in mind that the project is actually closely tied to the 5th question on the final exam. So everything that I'm doing from now on is actually tied directly to the final exam. And there will be a review. I've got probably 2 to 3 lectures on how to use the software, then I'll assign the project, and then I'm planning on meeting this Friday, so just keep that in your schedule that this Friday we will have a meeting I know we've been skipping about every other Friday or so. We skipped last Friday because I think last time I just showed you the software and posted a couple links there. And I don't know, has anybody downloaded the software yet or there? Okay. You probably want to download it after today's class and play with it a little bit there. So, well, and welcome to the rest of the crew there. So the software, I put a link on Facebook, but the name of the software is Logix Pro or whatever right there. I don't know how you pronounce that. Logix, Logic, or Logic. It's not a common spelling for logic, so and I bought the purchase version of the software. You have no reason to purchase it because I think it's got a 15-day free trial, and that's probably enough time to get there. It's pretty expensive. I wouldn't say it's expensive, but for a student it would be fairly expensive right there. So that's there. So first thing I'm going to do is, normally if you're going to run this software the first time, you want to have what's called the I/O simulator right there. The I/O simulator gives you access to all the input switch ports right there and all the output. Now this particular software gives us, it looks like 2 input modules, each with 16 inputs, and 2 output modules, each with 16 outputs right there. So that gives us 32 inputs and 32 outputs for any design we want to do. And what I'm going to do today is basically go through and demonstrate how this software is used and run a demo, and then there. The one thing this software it's got some really neat little demo graphics there. Unfortunately, it doesn't give you the ability to do your own there. And I haven't seen that, even with a paid version, I haven't seen where I can design my own really neat drawings, but at least we're going to go through a couple of their drawings, just probably one today there, and then go through a little bit more detailed, complicated one on Friday there. And then we'll get into the timers a little bit on Friday. So what I'm going to go through today is basically how we would put in push buttons and motors and things like that, and how we would do various inputs and outputs and tie them to these switches and show how they work there. So I'm going to do something relatively simple, and I like to split the screen this way because we're not using the BCD simulator right there. We're just going to use this part right there. So this is the way I normally split the screen right there. So these are my inputs here, and I'm just going to start off by just putting a push button and a output relay right there. So again, the way we specify an input, we have an examinative close, so we have to push the button for something to happen, and then we have a examinative open that we have to push the button to open it right there. So if we want to put a normally open switch, we just click on this right here, and this gives me a switch right And this could be a push button. This could be just real blank, a limit sensor. It could be a proximity sensor. It could be any kind of digital input that I want it to be. But this just shows it as a, as a relay, input relay. And we specify what relay this is by double clicking on the question mark, and we enter this as I1 right there /0 right there. And that's this switch right here. This is input module 1 switch 0 right there. This is how we specify that there. And then I'm going to do an output over here, right here. And I'm just going to call my output O:2/0 right there. So this is the simplest circuit that you're going to come up with right there, is that when I push this button, this motor will run right there. So, and in order to run this, we got to go through several steps. The first step is we have to switch it over to the PLC control panel. So this little push button there goes between these two right there. And believe me, I had run this software probably 6 months. It took me probably 10 minutes to figure that out. Is how do I get this that there? How do I get the simulation I/O box in there? All that stuff just totally went out the window since the last time I ran that. So last time I brought the software up, just showed what it looked like. I couldn't figure out how to use it last time. That there. I spent probably about half an hour, 45 minutes today bringing the software up and making sure I can remember how to use it right there. So now, before we can run this software, we have to download it to the PLC. Now, we don't have a PLC module sitting here that we're going to download it to, but this is, normally we would take the computer out to the laptop, we would plug it into the PLC unit, and we would download our code to the PLC. And this is what our code looks like right there. We don't write physical code here, we just do a ladder diagram. So I'm just going to download this right there. And so that it went through the process of if it was downloading to the PLC itself, right there. And then I hit the run button right there. Now when I hit the run button, this is actually running the code. So if I come over here and I flip the switch right there, and why is nothing happening there? Right there. Did I do something wrong here? This was working. That shows that switch is closed. You know what? I did do something wrong. Put it back in the program mode. Go back here. Double click on this. And I put I:1/0. I didn't put which port it was tied to. That there. And that's typical for first time you run the software in a year. So now I got to go back and again, it's fairly unfriendly. I got to download it again. I hit the run button again. Now when I flip the switch, you'll notice that this shows as yellow. That means it's active. This shows as active. This over here shows that it's active right there. So that's basically, I open the button, the motor switches off right there. So that's how we do a very simple push button right there. Now, if we want this to stay on after we start the button, we got to pull a little trick on it. We come back over to here and we put a rung on it. And the software is not the friendliest. I will tell you that right now. And then you got to move everything down to this here. And then we need to put in another rung here. And put it down here, and we label that O:2/0. We give the same name as this right here. When we give the same name means when I push it, that particular motor will stay on forever. Now, the way I've done this here, I've done no way of turning the motor off. Once I turn the motor on, it's on forever, right? So, again, I go through the process of downloading it, and then I run it. And once I close the switch, notice when I open it, this one is now active, and since these are in parallel, that motor is always on right there. So if I want to stop the motor, I need to put in a stop button, right? So the way we put in a stop button, which we can put it back in program mode, come back here, and we put in another switch right here, a normally closed switch right here, right there. And again, we move it up to here, right there. It's in series. And we're going to call that I:1/1 right there. So now when I run this right here and download it, run it, when I start it right here, I open it, it stays on. But now when I flip this one here, oh, that's an output. This one here, notice that I can turn it off. So that's how we would do a start and a stop on a particular motor right there. We just simply do it relatively straight, simple like that right there. And that's the basic process that we would go through. And we would make our circuits more complicated. I can tell you right now that you will probably see this particular type of circuit on the final exam, and you'll be asked to explain what each button does, what happens when I push buttons right there. So, you know, right here is question 4A on the final exam. You know, I can, because I just wrote that, wrote the solution for it. I can actually tell you what question this is on the final exam right there. Is you just need to know how you start and stop a motor right there. So that's the, you know, until we get into timers, we do everything with just this type of logic that there, and you know, we have a short period, we're not going to get very deep. Now what I'm going to do now is I'm going to close this circuit out, and I'm going to bring up one of their CAN simulations right there. Simulations. It's called the door simulator. And where is my door simulator? Right there. Well, here's my door simulator. It looks like this right here. So now, this won't work as it is. I have to write what they're saying is that I've got a garage door here, that I've got 3 buttons. One is a jar, which is not tied to anything right now. But that's simply, basically, you know, we would put that onto a sensor for, you know, to say that something's blocking the door. You know, we would possibly put that on as a bottom sensor right there. Right now, it's not tied to anything in the circuit. We've got these 2 buttons here, push, open and shut, or open and close. They call it shut right there. We've got our motors over here. We've got two motors, one for up and down. Now, in reality, it would be just one motor that would be reversed, but in order to make life simple, they gave us 2 motors for up and down, right there. And actually, here's our 2 buttons. Actually, a jar is, the jar means just the door is open. These are just lights is what they are. These are just lights, just showing us the condition of the door, right there. And that there, and this here, we're just going to ignore this. But we're going to write the code here for this garage door right there. So again, you know, I'm going to delete this whole circuit right here and just do a new one right there. And we just say okay. We don't, right there. And again, it takes up that there. I'm going to leave it with this screen here, just simply because I want to see the garage door as I'm working on. Now, if I'm working with a larger monitor, then this is a lot easier. If I'm working with 2 monitors, then typically I would put the drawing on one side and the circuit on the other side, but right now we're just going to go through here and we're going to just write the software. So the first thing I'm going to start with is we want to open the door, right? Now, in order to open the door, we go ahead and we put in a button right there. So let's go ahead and put in our garage door button. And let's go ahead and put our motor right there. And our button's going to be, and again, they're showing here our button is at I1/00. So I:1/. 1/00. And here is our motor right here. And our up motor is O:2/00 right there. So I can go through and I can download this. I can run it, and I can hit the open button, and notice that my garage door is open. You know, now as soon as I take my finger off the open button, it stops, right? Because I haven't put in that. Now, actually what happens on this particular one is it's kind of cute that there, if I keep opening it right there, it tells me that I burned up the motor because I kept opening it past the fact that it's already opened right there. So that there. So, but that's a simple. You know, now we want to go through here and we want to look at our limit switch to stop the motor right there. Now our limit switch is showing here that it's right there is when door is fully open, it's activated. So we want to put in a normally, and I got this wrong last time, and we may get it wrong again. If not, if I get it wrong, we just go back and fix it right there. We're going to go ahead and put in another, and you got to put it back in program mode before you do that. So let's go ahead and put in our limit switch right there, and we move it. We put this in series with that right there, and we call that I:1/03 right there. And this will, if it won't work, then I need to change that to a normally open right there. So again, I just download it and I run it right there. And in this particular case, this is not showing as activated, so I know I've got the wrong one. So I need to go back here, right click this, and change it to this symbol right here. That's how you can change it from a normally open to a normally closed switch. So now I go back to here, download it again. I hit the run, and notice that this is now active right there because the switch is not closed right there. So I go ahead and I open it, and notice it keeps opening. When I get to the top, you'll see that the limit switch will turn green and the motor will shut off. Right there. See, right there. So now I put in the safety of when I get to the top that the motor now shuts off right there. Now I need to do one other thing is now I need to put in my latch so that I don't have to sit there and hold the button right there. And then we need to put the stop button in right there. So we need several other steps to go through here. Now, normally you would sit down and you'd flow chart this and kind of figure out how you want to do it, but I'm doing it step by step to kind of get across what each of these buttons do as I go through that there. So let's go through here and stop it. Back here. And let's go ahead and put in, and I'm just going to show the ring rung here. That keeps it from going that there. I move that to here, and then I'm going to select this one here, and I'm going to put in another switch right here, and I'm going to move it down to here, and I'm going to call this the same name as the motor right there. So I'm going to put the caps on, O:2/0. And I'm sorry that that's hard to read. Can you read those at there? So now when I run this right here, download it and run it, I hit the start button right there. Right there. Oh, I got to hit the, oh, I did hit the run. Oh, it's, you know what? I've got the thing open and I haven't figured out how to close it yet. There. So before we go any further, I need to put the down button in right there. Okay? Right there. So let's go ahead and let's put the down button in that there. And I'll be honest, I did the same thing in my office too. That there. So let's just go ahead and put in on this branch here, right here, right there. And then let's go ahead and put in our motor here. And I'm not going to complete this. I'm just going to put in the, where I have to hold the button down right there. Actually, I'm going to go ahead and put the limit switch in. Now this limit switch is the opposite right there. So let's go ahead and put the limit switch in right here. So this one here is our close button, I:1/01. This happens to be our limit switch, which is I:1/04 right there. Now in the more complex software that you buy from like Allen Bradley for about 10 million ringgits a copy, it's not quite that much, but it's fairly expensive. Then you can put in these names, LS1 and that there. This particular $35 a copy for the full version doesn't really let you do much. This is just an educational software. And then we go ahead and we call this the motor down O:2/01. So now when I run this right here, download it, run it right there. If I hit the close button, it starts closing right there. And when it gets to the bottom, that limit switch should trigger and it should shut the motor off right there. So now we can bring the door down. We can open and close the door. So now when I hit the open button, it just opens all the way up right there. Now I don't have a way of stopping the midstream. We're going to add that to the circuit as we go through. Again, the whole goal of today's class is to go through this particular demo, and then between now and Friday, I'd like for you to go through this demo right there. So that there. Okay, so we can open, so we can close that there. Now let's go through here and let's put the stop button in right there. Let's stop it. I'm about ready to, I'm going to finish this particular circuit out, but I'm going to do it step by step. So let's now come up to here and let's put in another button right here for stop. And again, you see that our lights are actually tied directly to the motors. I:100 is actually tied to this. Well, actually, it's showing. Oh no, these lights are not put in yet. We haven't put the lights in yet, right there. So we'll add the lights at the last stop, right there. So okay, now let's go ahead and put in our stop button right here. And our stop button is I:1/02 right there. Right there. So that there. So when I push that there, and I'm going to just go ahead and run it. I'm doing this very slowly, one ring at a time, just that so you can follow as I'm doing it. I could jump in here and do everything at one time, and we'd have a very short class, but I'm not sure if you remember what button does what right there. So we go ahead and we run it here, we download it, and run. I need to hit the close button to close it right there. Right here. So it's closed. And then I hit the open button, and this one is the wrong one. This one here, I need to stop it. Another reason to do it step by step. Right click this, change it to right here, and then go back and download it again. Run. See, now my limit switch is on 03. That shows that it's active, that we can go up. And our stop button hasn't been pressed. So it's yellow as well. So now if I hit the open button, it's going to start going up. If I come over here and press the stop button, it will stop where it's at, right there. So again, we've got our garage door works like a garage door would in any shop or at their, going up. Now going down, we haven't finished it out yet. We need to finish the going down part of this here. So let's go ahead and finish the going down part by adding the stop button to it as well as the latch right there. So again, we stop it right here. We go to program and we click on this here and we add in our rung right here. We put in our other right. You got to bring it to the little red square. And why can't I get to the red square? And this one here is O:2/1 right there. So now when I run this, when I hit the close button, it goes down and continues to go down until it hits the limit switch. Now I need to go back and put in the stop button as well on that one right there. So we go ahead and stop it and put in our stop button right there. And our stop button is I-102. So I'm just going to click on this here just simply to. And this is, again, I:1/2 right there. Right there. And is that right? I hope it's right. Let's go ahead and open it. Up. I hit the run button right there. So we hit the open. It opens all the way cleanly. We can stop it midstream. We can continue opening it right there. And it's opened right there. We can now close it. We can stop it midstream. We can continue to close it. We can go over here and hit up, and it doesn't like that. It doesn't like that there. And why it doesn't like that is that you have to stop it before you, right there. So you have to go through and you have to add in those other motors as normally closed right there in order to show that, right there, that in order to turn on this particular branch, and I'm not going to go through and do all that, but again, you have to add that to this. And I have to leave something for you to do between now and Friday, right? That there. So, now you've got to figure out a way of using O2 right here. And again, we'll go ahead and I'll put one in here just right there. I'm running out of room over here. This is getting a little tight. I realize that there. You can see how these things start getting, got to stop it. And again, I'm going to put O2 in here, right there, and just simply to show that I can't, while that one is on, I can't activate right there. So I'm going to just go ahead and click on this one here, and I'm thinking it's this one here, but we'll find out here. And I'm going to say O:2/0 right there. Right there, so that if I'm going up, I can't hit the down right there. So let's run it here and see what happens. Right there. So we hit the run button. We hit the open button. Right there. So if I hit the close button, it ignores it now. I got to hit the stop button, then the close button. Right there. So you need to go back and do the same thing with the top one right there. But that's how we prevent the motor speeds going up, and I hit the close button. All of a sudden, both motors may try to operate at the same time. We get a fire. So this is a pretty good tutorial. I like the tutorial and the fact that this kind of shows you what would happen. Unfortunately, in real life, you don't have such nice tutorials to work with that there. But it's a good little learning tool. The only thing left to finish on this particular one, and again, we'd have to do the same thing with the down button here, because if I run this right now, and let's open it here, and then I hit the down button. Oh no. Let's close it, and then I hit the open button. Now that didn't give me the fire this time. It should give me the fire. Right there. That one's working nice and cleanly. That's a bug in the software. That one should give you the fire, because the other one did. While it was going up and I hit the down arrow button, the motor caught fire. This time, if it's going down and I hit the up, it just doesn't. Right there. So I don't know what's going on out there, because it's obviously a bug in the simulation up there. The only thing that we haven't done to finish this one, and as I said, my goal was to just go through this example up there, because after this point, I want you to go through this example, because one is you're going to see parts of this on the final exam, right there, and two is that this is a pretty good way of learning how to use the software. And I can't show you how to use the software enough. You have to download the software to run it. That's the only way you're going to figure out how to use the software right there. And what will happen is that you'll probably spend some time either in the lab or on your laptop at the hostels, or your laptop at the coffee shop or whatever, playing with this, and you'll end up with some questions. And you'll come here on Friday and you'll say, I tried to do this, how do I do that? Right there. I could go through this step by step and you'll miss something right there. Okay, the only other thing left is we got the 3 lights right there. And those are fairly straightforward, because the open light tells us that our garage door is completely open. So we can use our switch for that. So again, we come down here to this rung right here, and we go through here, and we put in a examine it closed. I put that there. I don't know, it always puts that there. And then we put in our output right there. And this is just our limit switch, I:1/03. And this is our light, which is O:2/03. So now when I run this, right there, and that light should be on right there. Open 02. You know what? (1/03), that's right. What's going on here? Well, I'm going to change this to a evidently it's got to be now the open one. So if I hit the down button, notice that it's no longer open, the light goes off. So it's got to be normally closed. That there. Right there. Right there. Now we're going to go through and add the next one for the get my brain here thinking here. The close shut light at there. So again, we're going to put this back to here, and this one here is going to be, and for whatever reason, right here. And then again, we have output right here, and this is going to be I:1/04, and this is going to be get my mind here thinking, and this is going to be my light is going to be O:2/04 right there. Download it, run it right there, and now my shut light is on. I open the door, my shut light goes off right there, and I can stop it right there, close it again, my shut light comes on. I hit the open button, take it all the way to the top, and my open light should come on. Everywhere in between, the ajar light should be on, saying that the door is partially open. Right there. Right there. So the easiest way to do the ajar is that if either of those lights are on, that you're going to have the ajar light on right there. So the easiest way to do that is to come down here and stop that there. And I'm just going to place a normally closed right here. And I could be wrong on whether it's a normally closed right there. And then I'm going to go ahead and put my output right here. And I'm going to call this one right here O:2/3. And that doesn't look right. No, none of my lights are on it. O:2/4. And O:2/4. No, /2 right there. Now, this may or may not be right here. We'll find out here. And it sure doesn't look right because, well, let's run first right here. All right, right now it's open. As soon as I hit the close button, the ajar light comes on right there because neither of the other lights are on. As soon as I get to the bottom and I hit the shut right there, the shut light comes on, the ajar light goes on right there. As soon as I hit the open button, if I hit the stop button right there, notice that the ajar light is on, telling the owner of the garage that it's partially open right there. So I hit the close, and it closes all the way, and then the shut light comes on, and it says that the door is completely closed, and they can lock up the shop. I hit the open button, it goes all the way back up to the top, and it says that the garage door is completely open, ready for business right there. So now as you look at this here, this is something simple like a garage door. Very simple process, right? But it took 5 rungs right there. And let me just, that's my full design for this particular process, for this particular design right there. Now, one of the things that this software lets you do is you can save this as a picture that there to include in reports, or you can just do a screenshot right there. But this is essentially how we run the software. Now, we're going to get more complicated. This is our first day actually seeing the software. And my philosophy is that I don't want to give you too much information that's critical at one lecture. So I don't want to add more to it. So Friday we're going to add more to it and get more complicated. We're probably only going to get a couple more steps out there. But one of the things that you can also do on this here, and I'm not going to do much with it today. I just want to kind of show you that we've got, these are our users, these are defined. We have our bits, we also have timers right there where we can have it, and we'll do quite a bit with timers, because timers is like, I have the example of, and let me pull up another example and kind of show that I won't talk about the example today, but simulation, dispatch simulator, for example. Right there. Yeah, that was a pretty complicated one, that there. The silo, where, again, here we've got a level sensor, a proximity switcher, and a motor. We'll do this one here. I'll probably have to do the one with the timer later. But, in timers, when we look at timers, we've got a time on delay, our timer number right there. We've got our time base, what we preset it to, the accumulation as it's running through the timer, where we go through and do a particular process where we want to, say, for example, fill up a tank with 2 or 3 fluids and then have it agitate for 3 minutes, 2 minutes, whatever, and then drain it and then fill it back up and keep going through that there. And then, of course, we can then have another part of our process, fill up our tanks as we drain this. And what this particular one's got, it's got a run button, and I haven't wrote the code for this, so I can't run this one here. They give you the nice pictures, but the code, you have to write yourself. Actually, there's a place to download it, but I'm not going to tell you where. That there. So, but what this particular one does is I have a container that will come over to here. Once it reaches this proximity switch, I turn this motor off right there. I release this valve to fill up the tank. When the tank is full, this level sensor will tell me that the tank is full. So the solenoid will switch off, and then the motor will continue it on down to the next one, right there. And then the next tank will come, this proximity switch would stop, fill it up, and then the motor will continue. So this particular one goes through and simulates emptying a tank and then going on right there. And this will be our next one that we're going to look at in more detail. But this one here has multiple sensors that we have to deal with right there. So we'll go through this. But timers is, for example, if we wanted to come up with an example, and there is one on the final exam where you have to fill it up, agitate for so long, drain it, or you have to heat them. You turn on an oven, you leave the oven on until you hit the off button, but you leave the fans go for 2 minutes in order to cool the oven, those types of things. So we have these timers that we have to deal with too, right there. You will find that we can do almost anything we want with these particular types of PLCs in terms of industrial control, right there. So I'm just kind of going through the first little example is our garage door. And our garage door looks like that right there. And we went through this whole process of figuring out how to program this garage door. Now, I would not expect you to be able to do this from scratch right there. This is your first time looking at it. I've done multiple, I've done this project before. I've done other PLCs where I've actually had to, in a school with a lot more money, we would probably have several of these garage doors built with a PLC attached to it, and you would actually go through and do a lab where you'd have to here we have just a little picture right there. So, but between now and Friday, I would really appreciate it if you just download the software and hold on, program this. Let me get this out of here. Cut that there. Let me make that full screen, and I am going to file. Let's go to the desktop and I'm going to post just that picture up on Facebook so that you can see what the final one looks like right there. So you don't have to come up with the design, but you at least go through the steps of entering it at there. Now remember, in order to see the garage door, you have to go to simulations and hit door simulator right there. And there's multiple. I got the bottle wine simulator that's right there. Goes through the process of that there. That's a very complex one, by the way, where we go through and we fill up the bottles and that there, and we can fill large, small. And this particular one actually looks at different size bottles and determines. Down here we've got our cases right there. We've got the batch simulator, which I showed earlier, where we've got two pumps right here. We've got the mixer, the high level and the low level. We've got a thermostat down here to measure what the temperature is right here. We've got our flow meter. We've got a heater. So we could come up with a fairly complex, circuit right here. Now we could get away with using part of this, for example, right here, right there. But this has got a mixer, and we've got the pump the liquid out when it's done. So we can fill it up to the low level or fill it up to the high level. We can mix it for so long, again, using our timer right there. We could, turn on this flow meter till it reaches the whole level, the low level, and then turn on this flow meter until it reaches the high level right there. So this one here is one that I may do for our final project right there, and I'll write this particular one right there. But this one particular one here, we've got our right there. We've also got some start and stop, that there. We may not use everything in here. We may not keep track of the temperature right there. We can ignore the temperature. So in this particular case, we can ignore the temperature in the heater, for example. Or we can set our temperature, or we can tell it what our temperature is, what it wants to be, and turn on our heater when it gets below a certain point, turn it off again when it reaches a certain point. So we've got so this is actually a good example for a project on using that there. Because we'll use every part that there. Because we've got two different level sensors, we've got two different pumps right there. We can ignore our flow meters if we want to, or we can use our flow meters if we don't, right there. We have our mixer that we can tell it to mix for 5 minutes, then drain the pump right there, and then fill it, then restart the process right there. So this is actually a pretty good one if you work in the oil and gas industry, because this is very similar to the type of thing that they would do. There they would definitely use and they may have a cooling system instead of a heater right there. But this is actually a fairly good one right here. Again, I don't have the code for it right there. And I could get the code, but I may tell you to do something different than what their source code says. I may only have you do part of this right there. So, that there. But this is where we're going. That there. But this particular type of program is different than what you've done in the microcontroller course, right there. Considerably different than what we use with microcontroller, and it's different than what we did with the robotics course, right there. I would say that you will most likely see some type of PLC in any type of factory system that you work with right there. So, as I said, I was going to keep it relatively short because I want I'm probably not that short. Yeah, 15 minutes. I'm within my 50 minutes to 75-minute range, right? Right there. I'm always in that range right there. So I'm going to stop there. Between now and Friday, look at this particular circuit right there. I'm going to post that picture along with the lecture hopefully later tonight.